In the previous video, we've seen that corresponding angles are equal to each other, right? So we've seen that we've established a relationship between the angles in this region, or the angles around the first point of intersection, and the angles around the second point of intersection. Now, we had established a relationship between the corresponding angles, right, in the two regions. Now, let us extend this idea and go further ahead and look at another such relationship between, let's say, this angle and this angle. Now these two angles, the first angle is around the first point of intersection, and the second angle is around the second point of intersection, right? Their vertices are different points of intersection. Now these two are not corresponding angles, right? Because the corresponding angle of this red angle would be somewhere here, right? This is not a corresponding angle. So what is the relationship between these two angles? That is the topic of discussion of this particular video. Now, what do we call these two angles? Well, firstly, these two angles lie between the two parallel lines. So they are interior to the two parallel lines. Secondly, they lie on alternate sides of the transversal. So firstly, they are interior, and secondly, they lie on alternate sides of the transversal. Therefore, they are known as interior alternate angles. Right? They are interior to the parallel lines, and they lie on alternate sides of the transversal. Now, to establish a relationship between these two angles, I need the help of a third angle. This angle. Now, these two red angles, they are corresponding angles. So let me quickly just assign them a few variables. Let's say this angle is x. Now because this angle is x, let's say this angle is x, this is y, and this is z, right? Just assigning them variables. Now I know that the two red angles are corresponding angles. This means they are equal. Therefore x equals y. So angle x is equal to angle y, right? That is the first thing that I can establish here. Secondly, I can also establish that this red angle right here and this purple angle, the two are vertically opposite angles, right? You have two lines intersecting at a point, and the angles are vertically opposite angles. Therefore, the second thing that I can establish is that angle y is equal to angle z. Angle z, that's a z, right? So this is because they are vertically opposite angles. I just write the short form. So that's the reason for this equality, and this is because of corresponding angles. I'll just write corresponding, right? Corresponding angles. Perfect. So I can establish these two equalities here. I can see that y angle y is equal to angle x, and angle y is also equal to angle z. Now from these two equalities, um I can infer that because angle z is equal to y and angle x is also equal to y. So angle x and angle z both are equal to the same thing. Therefore, I can um, I can conclude that angle x is equal to angle z, right? Because both of them were equal to angle y, right? So all of the three angles were equal, and therefore I can um, conclude this fact, right? Angle x is equal to angle z. Now, what is angle x and what is angle z? This is angle x and this is angle z. So I've just concluded that these two angles are equal. Now, what were these two angles? Angle x and angle z. They were interior alternate angles, and therefore I can conclude that interior alternate angles are equal. Right? That's what I just established in this video.